Hey everybody, it's time for another math video for Foundations Pre-Calculus. I realized this evening that not only do I not have videos on different squares, I don't even have a playlist yet for this. So time for me to quit slack-a-lacking and get at it. All right, so we've been working on factoring. By now, you should be really good at doing greatest common factoring, which it's okay. It's a fair amount of work because you have to try everything out. But it's not particularly difficult. You tree it out, circle the common stuff, do the division, we're good. This, I hate to say it, is almost fun because at least at the beginning, it's pretty straightforward. So we're gonna go through it slow because I realize I have absolutely no videos on this. And I think there's gonna be two. So I'm gonna start out with one that's just difference of squares. And then, of course, I gotta make it more complicated. We are going to throw in difference of squares with common factors. So it's like taking step 2 and putting with step 1, making something new and magical. Okay, this is cool. All right, so first thing we need to know. In math, when you say difference, it means something. It specifically means subtraction. I hope when I pause there, you'll yell subtraction at me because that would be so cool. Kind of like Dora the Explorer, just more math. I should apologize. It's like 8 o'clock at night and I'm really tired, so it might be a little bit weirder than usual. Okay, so that's the first thing is there's going to be a subtract sign in this. If there's no subtract sign, it doesn't work. Done. End of story. Second thing, it's got to do with perfect squares. Now, it's not called difference of perfect squares factoring, but it should be. So let's look at a list of perfect squares. Okay, so 1 squared. And just to humor everybody to make sure we're all on the same page. So 1 squared means 1 times 1, and that's 1. Not very exciting. This is equal to 2 times 2 is equal to 4. This is where people screw up. 3 times 3, it's 9. If you wrote 6, you are completely forgiven because that happens all the time. Because your brain sees 2 3s and you're like, oh, we are multiplying. Remember, the little dot can mean multiplication. I could be writing in this brackets, but today it feels like dotty. Okay, so you should know 1 to 12. And I was ranting at my poor grade 10s today. I'm like, just learn your multiplication tables. Just do it. Okay. So I'm not going to write this out because you know what it means. So 16, 25, 36, 49, 64, 81, 100, 121, 144. I think as a person who was in grade 10 math and going into grade 12 math next year, learn your multiplication tables. Get it over with and I'll quit bugging you. Okay. Sometimes we don't have particularly great days. And sometimes you get a big number and you're like, I don't know. So I need something squared. And I know my answer is 169. So, oh, I guess I should have been doing this. Let's see, got my fancy calculator. I think this is a Casio. Now it's bugging me. Oh, no, it's a Sharp. Ah, look, made it. I don't know what that did. Okay. It has an x squared button. So if I want to go 7 squared, 49. And that's exactly the same as going 7 times 7. But you already have that memorized, right? So 11 squared is 121. Got it? So if I'm looking, if I have this start, and let me do it this way. I can go 12. And then on my calculator, it's this x squared button. That's the key punch. Okay. I think that's what it is on most calculators. But this is going backwards. I want to know what number times itself, that's why I left a blank here, is 169. So 169. Do you remember what the keying is? Because I think I just did mine backwards. I need, and how well let's try and focus. There it is. It's teeny tiny. A lot of calculators have this, I don't know how to say it, as a key you can get to easily. For some reason on this calculator, the square root is kind of hidden here with the x squared button. Kind of makes sense because they're like the opposite of each other. Anyway, I'm going to try 169, and then I'm going to go second and hit that. Oh, yeah. I'm pretty sure I know what's going to happen. It's going to say error. Yes. Okay, so my calculator, it lets me put the square root button in first, and then 169. And it tells me the square root of 13 is 169. Focus. We're back in business. Okay, so that was the square root button, and then 169 is equal to 13. If I don't like that, I guess you could sit here and go 12 squared, 144, 13 squared is, this wouldn't take that long to get there, but use the square root button. What about the square root of 256? Okay, so again, on this one, square root button first, 256, boop, is equal to 16. Somebody was bugging me today and guessed it was 14. It's like, I don't know the square root of 14, but I know one for 16, or square root of 14. Anyway, the point of this little section is if you don't know the square root of it, use the square root button. Or if you don't know if it's a perfect square. Oh, for example, square root 50. I don't know, but that's not fitting our pattern. So at least for today, for this video, something's wrong. Copy the question out right, incorrectly. I don't know, but it should come out as nice whole numbers for you. That's where I'm going. Okay, so we know it's going to have a difference. There we go. Hold on. And we know there's going to be perfect squares. So the pattern, and it's a pattern that you just learn to recognize. Love it too, just like me. Is it's some kind of, excuse me, perfect square. Whoops. I'm going to write this, and then I realized I missed something. Minus a perfect square is equal to, no, I'm not solving the equation. That's it. It's a perfect square minus a perfect square. What I forgot, I could go ahead, is variables. So let's do that before we get too far ahead. And then we'll come back to that definition. So n times n, and multiply that together, n squared. You know that. times b squared. And in class, by the time I made them do this, I mean, in a good way, said, we get it already, we get it. Because they knew this was sigma c squared. I said, all right, you won't be that way. Gonna make it more harder, harder. And I said, well, what if it's x squared times x squared? And they made me quite happy because pretty much everybody knew that was going to be x to the fourth. Okay. So, sorry, where am I going to go now? M4 times M4 is M, yes, you got it right, M8. Okay, because when you multiply, you add your exponents. And way back here, remember, there was little imaginary ones. Ta-da. Ooh, big numbers. G to the 10th times G to the 10th. Gamma, shout it up for me. Don't you watch this with your children? Teach them math. Teach them math this way. So much easier than the textbooks. I'm going to stop because I'm sure at this point my students would be yelling, we get it, we get it. Add the exponents, yay. All of these are squares, or sorry, all of these are perfect squares. What do you notice? Whoops. Let me put one more example so I can say this properly. S5 times S5 is going to be S10 and T3 times T3 to T6. And it's going to have you make a conjecture, which is a very math 20 thing. And I realized I didn't give you enough data. Okay, so all of these are squared terms. Because remember, squared is something times itself. It doesn't necessarily have to happen to, but it usually does. What do you notice about all these exponents over here? Yeah, they're even numbers. That's how you know it's a perfect square. Because up here, if we wanted to check if something was a perfect square, okay, I don't know if 121 is a perfect square. 121, boom. Yeah. Oops, you can see it. It was super easy. You use your calculator. If this comes out as a decimal, it's not a perfect square. However, as far as I know, excuse me, can't do that with variables. Maybe your calculator can, mine can't. So all you need to be able to do is, as long as this part is even, you can always work back to figure out what the square root is. So if we do the square root of x squared, it's just x. I'm going to make your life a little easier. Put a little 1 there. Now, I'm not going to mock you by doing y squared and things like that. But let's look at x to the 4th. If we take the square root, we get x squared. So the key here is to be able to take square roots, and all we're doing, maybe one more. S to the 10, square root is s to the 5. So really, all we're doing is dividing that by 2. So when you take the square root of variables, you're just dividing your exponent by 2. I'll show you in a second why but I'm going to write that down before I forget. So to take the square root that's an of. Eek. Divide the exponent by 2. If your exponent is an odd number, like S3, you can't do it. Something else is going on. That, again, is left for our next video. Now, I'm going to show you why. Remember when we did square roots, the deal was you treat it out. Now, I can't really tree out S10 other than going 1, 2, 3, 9, 10, right? Because that's what S10 stands for. It's 10 the less is there. If you're doing a square root, you circle sets up 2. And surprise, 1, 2, 3, 4, 5. And you multiply them together because you'd go S times S times S times S, S. And away you go. You would get this. So do I need to do this every time? No, of course not. Just divide it by 2. Okay, so let's review. We're going to need a subtraction sign in there somewhere. We're going to need some perfect squares. And I forgot to say, you're going to need a variable too. And the pattern is going to be a perfect square minus a perfect square. And you're probably going, no, I still don't know what you're talking about. Okay. So let me write that pattern down. So I'm going to start with one of my perfect squares. Means 36. 36 is a perfect square. And then I need a subtract sign. And now I need some variables. So I can pick anything I want off my list. Oopsie, sorry, that's not straight for you. I'm going to put b squared. This is the pattern we're looking for. Okay, so this is the pattern. It's going to be something that I can take the square root of. Okay, so if I go square root 36, it's 6. Perfect square. And this has to be even because I know to take the square root of that, it's just going to be divided by 2. So I can do anything like this. 25 minus x squared. Okay, that's boring. It's almost the same thing, yeah? I could make it m squared minus 49. So it doesn't matter whether the number's in front or the letters in front, whatever. It doesn't matter, okay? But it's something squared minus something minus the perfect square minus perfect square. We can make it more fun and go like 144 m squared minus 16. Wait a minute, that's a bad question. We'll talk about that later. 49 y squared. So I can get more complicated. It doesn't matter, but 144 and 49 are both on my list, right? When I would do my formula sheet for this chapter, first thing I'd probably do is just write a list of perfect squares so that I know them right away and I don't have to do any work. Just look at my list. What other variations can there be? I've got all these squareds. I could go g to the 10 minus 1. The minus 1 always messes up people. One's a perfect square. It's on our list. As long as this number is even, we are spectacular. Oh, I could do S10 minus T6. So it can't be all numbers because then it's just an order of operations kind of thing. But it can be numbers, variables, and numbers, and you can mix them up and put them together. Ta-da! Those are all the different variations. Okay, so you got the pattern. Oh, also, how many terms do we have in each of these answers? Yeah, 2 terms. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. If it doesn't have 2 terms, it's not a difference of squares. So let's review what we have to have, and then I'll teach you how to do it. So you must have a subtraction sign. You must have both terms must have 2 terms. If there's 3 terms, it's not a perfect square. Done. Those are the easiest things. And the numbers, the variables, must be perfect. No. All right. Squares. Oh. Oh. So sorry. So we've got this. Now, let's take a look. I have a sheet that's got stuff on it, but maybe I'll just do a few more. Well, actually, we're going to factor these ones because it's really sweet. So 36 minus b squared. Okay, so here are your steps. This is how you do it. And it's just learn the steps. There's an alternate way to do it, but it's a lot of work. This is just learn it. Probably put a couple examples on your formula sheet. You're golden, don't even need the steps. 1, draw 2 sets of brackets. Okay. Boom, like that. Number 2, take the square root of the first term and put it in the first 2 spots. Right, the square root of the first term in the first spot. Of both brackets. So square root of 36 is 6 and 6. I'm just going to go scribbly boop and put an arrow. Okay. Third step, and there's only 4 that you have to do. There's a 5th one that I'll show you because I can. Third step. Right, the square root of the last term in the last spot in both brackets. I hope you notice it's taking me significantly longer to actually write these out than it does to actually do it. If I, again, get the little note here, square root of b squared, it's going to be b. So b here, b here. It's only 4 steps. Apparently I'm getting tired of writing. Okay, so we put a plus in here because we need something between our terms and a negative there. Boom, done. That's it. And like I said, if you didn't have to write all that stuff out, you'd be done already. You'd be done all of them by now. Okay. I should put a little star by this. There is a reason that we put the plus in the first spot and the negative in the second spot. For now, I'm just gonna ask you to trust me. Today I actually remembered that, oh, now his name went away. Bedard. Connor Bedard? I don't know, he's like a famous hockey player, dude. I think he might have been from Regina. If he gave you some hockey tips, you'd say, yeah, okay, he's really good. I should trust him. Well, I'm not Connor Bedard, but I am Joanne Mortensen, and I've been at this a long time. So trust me. It just works better that way. It flows better, it looks prettier, whatever you want. If you insist on putting the negative and then the positive, I'm not going to mark it wrong. But if you're in trouble, I'm not going to feel sorry for you. Honesty. Late at night, I'm making videos. Okay, so enough of me blithering about. Let's try some of these other questions. Excuse me, I'm just going to copy them from the top of the page. 25 minus x squared. Okay, here we go. Step 1, hold on. I don't know where this sits for you, so I'm just going to move my little picture up there a little bit. 2 sets of brackets, boom, boom. Square root of 25 is 5. Square root of x squared is x. Plus and a minus. Somebody timing that? That was pretty good. Okay, oh, I forgot about step 5. Step 5 is I'm just going to show you why there's the magic. And remember, when you factor, you can always multiply back to get the original question, right? We did that with greatest common factors. We would distribute. Well, look at this. Distribute it. This is a binomial. This is a binomial. We can check it by FOILing. How many of you just rolled your eyes at me? Don't lie, it's okay. All right, so first times first. 5 times 5. And I use Brian's method because it's just easier for me to teach this way. And then we go 5 times negative x. Now, be careful, don't lose that negative x or the negative on the x. That's outsides. Now we go insides. And then we go last. X times minus x. I just want to make sure, see, there's a negative x here, so there's one there and one there. So we're good. Now we're going to multiply. So this was organized. 25 minus 5x. 5x and minus x squared. So when we go to put it all together, I'm going to do it in the order that it's written, and then we'll talk about if it really matters. 25. Now, if we look here, this is where the magic just happened. I've got a +5 and I've got a -5, so it disappears. Boom. Minus x squared, which is where we started. So FOIL can be used to check. I wouldn't expect you to do it all the time, but there'll probably be spots in the test where I say, check your work. You're like, wait a minute there, teacher. You always tell us to put the variable first and then the numbers. Yeah, you can. Minus x squared plus 25. That's completely right. I'm not going to argue. But you have to be able to recognize that this is the same as this. It's important here that the negative is with the squared. You can't just put the x squared at the front and then 25 at the back. That won't work. Anyway, I'm going to stop talking about that because that's not going to be helpful. But you are allowed, if you have minus x squared plus 25, to just, if you're doing this chapter, just rewrite it like that. So, all right, m squared minus 49. Yeah, 2 sets of brackets, boom. Square root of m squared is m, right? Square root of 49 is 7, 7 plus minus done. That's it. Done, 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 done. Ta-da! There you go. Okay. I'll finish these ones up and then I think that's as far as I'm going to go in this video because I have a feeling it's getting long. So I have a 144 m squared minus 49 y squared. 2 brackety bits. So we have to be careful. We need the square root of the whole first term. So the square root of 144 is 12. But I also have an m squared there, so I'm going to need an m. Now on the back, I've got square root of 49 is going to be 7. And then I've got y squared, so 7y, and a plus, and a minus. Oh, I was done. G10 minus 1. Brackety bits. Oh, my goodness, you should just pause the video and finish these last two. You do that. I hope you did. All right, square root of G10, remember, you're going to divide whatever this power is by 2. So that's going to give me G5 and G5. And this part always feels weird. Square root of 1 is just 1. 1 goes there, and yes, we need them. Plus and a minus. Ta-da! Oops, not to that yet. And I guess this is the example where we just have variables. We don't have to have numbers. So S10, that's going to give me S5, half as much. And T6 is going to give me T3, square root, plus, minus, done. Excuse me, as is the video. Thanks for joining me. Sorry, thanks for joining me, and hope to see you on the next one. Bye.